Hello. Hello. Hi guys.
Okay, I'm gonna wait for some people to come in. I think I'll wait 3 minutes more just to give people time to come in, and then I'm going to give a description of what you're going to be doing in these lab sheets. Although to be clear, you probably should have had a look at them already and given them a shot, at least one of them a shot. Yeah. Dang, I'll have to make an announcement. There's Next week we only have one lab sheet, so it's a bit easier for you. It's also time for you to work on the assignment for next week. I'll put an announcement into onto the LMS. But yeah, I'm gonna wait just a few
Hi,
minutes.
doctor. Hi,
Hi,
doctor.
madam.
Sorry. Yeah. Do we have exam like anything online exam or anything? No,
No, for
right?
this subject there is no exam. Your
Cool.
entire mark is based on your assignments.
Yeah, sounds good. I like the final assignment. It's like a more practical one.
It's a more creative one, yes.
Yeah, yeah, yeah. Third one.
Yeah. Yeah, so it's 20% for the first assessment, 40% for the second assessment, and 40% for the third assessment. So second and third assessment are the same weight as each other. Yeah. Okay. All right. One more minute and then I'll give a introduction. Just make sure that everyone gets over. Okay. I'm now sharing my screen, showing you the labs we're going to be working on. Hopefully by now you know where to get the labs. So module 3, we're doing lab number 5 and 6 is what it says when you open it up, but it's just under the module 3 lab, just like normal. And let's talk about what you're going to be doing. So last week we did lab sheet 3 and 4. Lab sheet 3 and 4. Uh, Lab sheet 3, we were looking at training machine learning models. We're looking at like the basic ideas that underlie training machine learning models, and that's all machine learning models. That's linear regression, that's neural networks, that's regression trees, the basic ideas where we have the input is a point in space, and the model is kind of like a surface in that space. If it's a 1D input, then it's a line. If it's a 2D input, then it's a 2D surface. If it's a 3D input, it's a 3D surface. And what that really tells us is that for any input value, the model is going to give us an output value. And then in the space that those points are, the model's going to learn the correct value. And that's like a surface in that space. I guess the most important part there is just that, yeah, for any input, it can give you an output, but it's only well defined in the space where we have the training data. That was the basic idea. And we looked at regression and we looked at classification, where classification is kind of like a coloring of that space. That classification still works for images, but instead of it being a two-dimensional input, the images are like a million dimensional. If it's 1,000 by 1,000 pixels, there are a million pixels. So the input is a million dimensional. And so there's space of those pixel arrangements that are classified, and that's we want you to have a general idea of what that's like, in the sense that you know that the model can learn some decision boundary in that space. These images look like cats. These images look like dogs. and it's learned a decision boundary in that space. And then once we've got a model that can do that, the lab sheet 4 is talking about evaluating how good that classification is. And we looked at uh, we looked at confusion matrices, we looked at recall and precision, and we looked at problems that can occur in the data set, especially if it's biased in some way, if the data set is biased in some way, so that the model doesn't learn very well. And if you have a small data set, then that's a bigger issue because the model has there's more to learn, less to learn from, right? More it has to like figure out from those images. And so those are like the basics of getting a model and knowing whether it's good. And that's the as we did last week. This week we're looking at image data. So last week we're looking at tabular data. This week we're looking at image data. And we're going to look more high level now. Now that we know those basic ideas, we're not going to try to plot an image in a 3D space or whatever. We're just going to look at images and we're going to look at what the model can do and what the model should do. So lab sheet 5, all we're going to be doing here is we're going to be looking at sort of the computational level of what the output of the model when it's doing classification is. Like what it's a series of numbers, but what do we do with those numbers? What does it look like for a literal classification? And in this case, we're going to look at ImageNet, which has 1,000 classes, which means that the model is choosing between one of 1,000 things. That's classification. We're just going to be looking at model outputs. We're not going to be training anything in lab sheet 5. And then we're going to look at detection. So that's classification. That's what we're going to be doing in the first part. Then we're going to be doing detection. Same idea. We're just going to look at the output. And remember that it's got output boxes and classifications per box. And what does that look like literally as numbers in a computer? What do those numbers look like? And that's what we're going to be looking at for detection as well as classification. And then finally, we're going to be looking at segmentation. Same idea. What what does the numbers coming out of the model look like for segmentation? In particular, we're going to be looking at semantic segmentation. We're not going to be looking too much at instance segmentation. So lab sheet 5 should be reasonably easy. We're just kind of looking at what the output data looks like. And then we're going to look at lab 6. We're actually going to start training a model. Remember at the end of the lab, we talked about transfer learning and fine tuning and using a pre-trained model. Well, in lab sheet 6, that's what we're going to do. We're going to get a pre-trained model and we're going to train it on a new task. We're going to see the model get better, and then we're going to diagnose training with those hyperparameters. We're going to try and choose good hyperparameters so that the model trains well. And we're going to do that for 2 different data sets. We're going to do fine tuning on a small data set that you prepare so that you're used to the idea, like what even is a data set? What does it take to prepare a data set? And then we're going to do it on a larger data set so that we can get sort of the nicer curves. Because if you've got a small data set, it jumps around too much. There's sometimes nothing you can do to make it work for a small data set. Sometimes there is, sometimes there isn't. And so lab 6 is about training the data set with that pre-trained model transfer learning on these 2 different data sets. All right. Hopefully that makes sense about what we're going to do. You're feeling comfortable. You've done the previous labs. You're up to date. So get on with it and let me know if you have any questions about any part of it. And if you have questions about the lecture as well, you can ask about that as well. Good luck. Let me know if you have any problems. Since there's no questions immediately, I apologize. I'm just going to duck to the bathroom real quick. I'll be back in just a couple of minutes. So if you have any questions, hold them or put them into chat. I'll be back in just a minute or two. Okay, sorry about that. I am back now, and you can ask any questions if you had them while I was away.
Hi, Brandon.
Hi,
Um,
Lasanta. What's up?
um, I changed it to the customs on the
Hmm.
way it's, that, and then I try to copy that URL from the given uh, websites, and it
Context
give
also.
me errors.
Okay. Did you follow the extra instructions about how you have to download it and then you have to right click and copy link after you've downloaded it?
Download this small version of. No, I didn't do that. Sorry. Uh,
So
so
can
you
you?
have to download this from.
So I'm not sure where you're looking. I'm just going to share my screen and show you where I am looking, and you should be
Yeah,
looking. So you've got the image name, and you're selecting custom,
yeah,
and then you put a URL in here, and you say it's giving you an error.
yeah.
Up above, you have this. I'm going to zoom in a bit, actually. You have this optional instructions. You have to
Okay.
click it, and it will come up with some instructions. And so you got to make sure you get the direct download link. And so for Firefox, that's up here. You'll get a download thing around here if you download something.
Okay.
And then you have to right click it and select copy download link. So you have to have downloaded it, and then you have to copy the download link after you've downloaded it. It's just because it's like a proxy issue where
Uh,
you will request it, well, you will request the image, and the URL would eventually get to an image, but it doesn't immediately get to an image. It actually contains instructions for the browser to go to a different web page, and then that web page is the image. And so you need to let the browser follow those instructions to the end point to get to the image, and then you can copy the download link once you've got the final, once it's downloaded the image. Does that make sense?
Um, yeah, yeah. When I hit that, it goes to the pre-download and then the picture. Um,
Sorry, say again.
yeah, it's showing the image. It's I don't know the same image. It's like
Hmm.
pre-download uh, window. Not sure whether it's the last one. Uh, is that the last uh, last destination to get the URL? Like,
Uh, so following these instructions, when you have downloaded it and you have an image file on your computer, like it's gone to your downloads folder, then
uh,
that means that the
using
browser.
sorry, you using the download folder.
No,
I'm
we're
not
not.
sure. I'm sorry.
We're
Sorry
not. We're
about
not
that.
using the downloads folder. We're just making sure that the computer has actually downloaded the image to the downloads folder. That means that the browser has found that final step of the chain and
Uh,
has actually got the image and downloaded the image. Theoretically, you could write some code to follow each step, and then when it knows it's a JPEG, not actually download it. But it's just much easier to just let the browser download the image, and that means that the browser knows where the final step of the chain is. Once the browser knows where the final step of the chain is, you're going to copy the download link. So I'm actually going to show you sort of
yeah,
it in action. So can you see this change to a different thing? I've just searched
yeah,
cafe, just a random thing.
yeah.
Let's grab an image from the cafe, from cafes. I don't know. Let's go some things. We got some people. No, let's just give it a random thing. I'm gonna give it this one. This one. All right.
Yeah.
So I want this image. So what I'm gonna do is I'm gonna click here. My thing is not working. Hold on, let me just. Or is this one I can't take? Maybe it's a Canva only. Why can't I click this? What's going on? Okay, the browser's not working. Let me try a different browser. Uh, Pixels, Cafe, and it was this one. And we click this down and we go small. We go download selected size. So that
Okay.
downloads it, and it's going to go down to my downloads folder and click save, and it's done. And I can't in Chrome. You can't right click it. You have to go to the downloads page, and then you got this link here, copy download link. So this is has already been downloaded to my computer, but I still want to download to my computer. Now I can find this copy download link and I click that, and that's copied that to my clipboard. Now it's copied that to my clipboard. That's what I can paste in here.
Oh, okay, yeah. So it's in my local machine and that links works, huh?
No, it doesn't link to your local machine at all. These are separate. It's just that once you've got it on your local machine, that means that your browser knows where it is. And
Oh,
that's
okay.
how, and once your browser knows where it is, that's how you can copy it. If you copy before, you're copying like a proxy link, a link that like ends up not, it doesn't directly go to the image.
Uh,
And I'll just make sure that it's able to run with that. Actually, it'll take a minute. Anyway, yeah. If you're having any more trouble with that, you're still having errors, then you're welcome to share your screen and we'll have a look at the error.
Still, I find the image in my local folder.
Please
Uh,
do not use the image on your local folder. We're not using the image from your local folder.
okay. Find the, uh, it's still not showing.
All right, can you share your screen?
Yeah, I do.
Let's have a look at what you're working with.
Yeah. Mm, share screen. Mm.
Yeah. So what browser are you using?
This is Chrome.
Chrome. Cool. All right. So can you get an image? Have you downloaded an image that you want to use?
Downloaded here.
Okay. Yep. Okay. Can you go to the three dots to the top right?
Yeah,
Yeah. Click that and go downloads. Yep.
yeah.
And then you've got this, there's like a picture of a chain link.
This one.
Yeah.
Yeah.
You left click that.
Left click.
That's right click.
Sorry.
Left click. Okay. It's been copied to the clipboard. Now you can go to now it's ready to go. You can just go to the lab and paste it in.
So this is, I can copy this, huh?
It is already copied. It's already been done.
It's
It's been
already
done for
done.
you.
Okay. Lab.
Yep. Custom URL and just paste that in. And then you hit play.
Okay. So,
Seems to be doing something. Oh,
yeah.
you downloaded a big one. You didn't download a small, but it's fine.
This is not the one.
So when you download it, you should download the small one because it it makes everything work better.
Okay. I do it again.
It's fine. It's fine. It worked. You
It works.
can see that it worked, so that's fine. Just
All
for
right. Thank
any
you.
other images, you would want to download the small version.
All right. So do we do this for another one or just one?
This is just for you to look and understand what it's doing and to explore. There's no um, requirement that you try five or anything like that. This is just for
Yeah.
you to explore and see what it says. So look at those distribution of classes. Does it work? Does it not work?
Uh, it works, huh?
You reckon that works? You reckon that's a groom?
Chrome. Yeah, yeah. It's just how to know,
I don't know if this is a language thing, but that in English the the woman is called the bride. The man is called the groom.
Yeah, one or the other anyways. This is identified.
Okay, sure.
No, so this mean the higher prediction
Yes.
on this on the groom as this identified as a groom, huh? Yeah,
Yeah.
rather than gown or hummingbird or something, yeah.
Yeah. So there's 1,000 different classes it could choose from, and so we're only seeing the top 10 over in the top right. But if you look at the bottom graph, you can see what it looks like across all 1,000 classes. You can see there's like two big spikes,
Yeah,
and
it's fine.
that's where the groom and gown are in the list of classes.
All right. So
But
the
the
1,000 passes identify the groove, yeah? And
this is different views on the same data, right? So the model has output a distribution, has output of a score for each class, each of the 1,000 classes, right? And it's given the highest score to groom and the second highest score to gown. And
and
in the bottom part, we can see that groom is class index maybe 970 something. And the gown class index is class number 560, or maybe closer, I'm not sure. Maybe 580.
yeah, this one.
Right. Because there's 1,000 different classes, and we identify them by the index as well, right? The number, class number 5, class number 100, class number 700, right?
So this is it's similar like a probability distribution classified as groove.
Exactly.
Okay. Yep. Yep. Understood. Thank
Cool.
you.
No
How
problem.
many parameters model?
Manoj, are you
Okay.
talking to me?
How many parameters like this model?
ResNet 50. Um,
50 billion? Oh,
no, no, the 50 refers to how many layers. As for the number of parameters, I don't actually know. It's in the
okay.
millions.
Millions. Yeah.
Yeah, millions of parameters. I don't
Cool.
know exactly how many parameters. I've just stopped you sharing, Lasantha.
And then
Yes, Ablado.
question. Now,
Mm-hmm.
on the the Mario pixel,
Mm-hmm.
Mario
Yes.
composed of red, green, and blue, right?
Yes. Like all images are. Yes.
Yeah, that's the prime three images. Now, to create a yellow, that is a combination between few of this pixel, correct?
Uh, yeah, so every pixel on every screen that you see has a red, a green, and a blue component. So if you have a pixel which is yellow at the final pixel that you see, that means that it's got a particular combination of red, green, and blue which appears yellow.
So, do the computer put some number on it one? I mean, to say particular, say assuming a yellow on that particular pixel on the Mario, they assign
Mhm.
a number or
It assigns a number, sorry, the image data contains a number which tells the computer's screen how to present it, and it contains a number for the red, a number for the blue, and a number for the green. It does
yeah,
not
but
contain
it's
any like yellow number.
oh. So how do the final one assess the yellow one? I mean, if the yellow is a combination of the three, they how do you
How
identify
does
the
so sorry, I want you to be a little more clear about who or what is doing what kind of identification. You asked, how does it identify
ah,
the yellow?
so we can
What do you
identify
mean?
yellow because we can see it, right? But how is the computer identify yellow?
The computer doesn't identify yellow. The computer sees red, green, and blue, and that's it. And then it displays different amounts of red, green, and blue.
Yes,
And if you have a particular combination of red, green, and blue being presented together at the same time, you get
yes,
all the other colors.
of course. I understand that one. Okay, all right. Okay, thank you very much. So there's not I mean the actual computer doesn't assign any number on yellow. It's just a combination of all these three things, right?
Yeah, so yellow is a certain amount of red, a certain amount of green, a certain amount of blue, all shown at the same time. That will
Yes,
produce yellow. Same thing if in like basic art class you have primary colors and all the other
yes, yes,
colors
yes.
are a combination of primary colors. It's exactly that what's going on here. We have primary colors, our primary colors are red, green, and blue in computing, whereas when you're using paint, it's red, yellow, and blue, I think.
Yeah, yeah, yeah.
Yeah.
But during the addressing the classification, as we go down, how did the computer, do you think yellow? I mean, how, assuming there's a yellow pixel, do this necessary to be identified at all? Not at all, or?
Right. So the neural network part of the
Yes.
computer is going to be able to identify yellow as a color because it's going to see yellows in certain places, right? Like it knows what yellow looks like because it's seen things that are yellow in this. You know how there's like that weird like stoner question, like what if my red's not the same as your red, right?
Yes. Yes.
Uh,
Yes.
it's it's kind of the same thing with neural networks. Like it has an idea of red. It's not the same as our red, but it
Yes.
has an idea of red because it sees a bunch of things that are red because
Yes.
it has whatever inputs that tell it it's red. And in the case of neural networks, that's like it's high in the red value for that pixel and low in the other colors in that pixel. And same thing with yellow. If we want to say, does the model know what yellow is? It knows what yellow is because it has seen colors before and knows how to handle colors that have the exact combination of red, green, and blue, which means that it's yellow when it's presented on a screen. But the computer itself only sees numbers and it's still only calculating based on numbers. But yellow is a number in a sense,
A combination of numbers of
a
a
combination
red,
of
white, and
red,
blue.
green, and blue. Yeah.
Okay. Correct. It's clear.
Does that
Thank
make
you.
sense? Yeah, cool.
Thank you.
Good.
Brandon, so what is the point, like, so of the first question, the first reflective question?
First reflection question. All right, let me have a look because I don't know them off the top of my head.
Oh, sorry, so I can
Yeah,
share
that's
my
fine.
screen.
I can find it. That's
Yeah.
fine. Reflect question
So
one. Which color channels contain information about the yellow stripe? Is this what you expect? Explain your reasoning.
yeah.
What are you
Well,
thinking?
I get some help from the Gemini. So it says yellow, and it says that
Mhm.
like it's a combination. I think this is the set. It's formative, therefore, but I still don't understand after I read that. This is the answer that Gemini provides.
So it's not your answer.
No. Because
Okay.
I was getting help from here because I was
Sure,
like, what
sure.
is the
All right.
point? Yeah.
So, okay, so the let's look along the bottom half of the image. I know they're kind of on an angle, but we're going to count the number of I think it's textures there. It looks like it's kind of textures or maybe
This
crayons or
here,
something.
like that part, the red, green, and blue.
Just looking at the original image for now.
Yeah.
So which one, let's just make sure we know which one is the yellow crayon.
Yeah.
I think the crayons. We're going to call them crayons. I think
Yeah.
crayons. Okay, that's the yellow crayon. So on the
Hmm.
bottom half, that's the one, two, three, fourth crayon, right?
Yeah.
Okay, so it's the fourth crayon. Now let's look at the ch color channels. So let's look at the red color channel. For the fourth crayon, is it bright or dim?
Oh, in here, I said
The
it
fourth crayon.
is
Yeah,
bright.
it's bright. Okay, so for the red channel, it's bright.
Yeah.
Okay, now look at the green channel. The fourth crayon. Is it bright or dim?
Oh, bright.
Okay, so it's bright in the green. Now the blue channel. The fourth crayon. Is it
Um,
bright or dim?
dim.
Dim. Okay, so that means that the fourth crayon is bright in red, bright in green, dim in blue.
So that is what made the color of the yellow.
That
Yeah.
makes yellow. Yeah.
Okay. It doesn't make sense at all. The Gemini didn't even explain this.
Yeah, it's
Okay.
it's trying. It's trying its best.
I was like, what is he talking about? Okay, got it. Thank you.
Yeah, cool.
Yeah, no, I've done everything, but I'm sort of like going back and reread them. So to do assignment
Yeah,
two, we need to do this and
you
also
need
the
to do,
next one, which is
yes.
the
Yes, you need to have
collapses,
done lab six. Once you've
which I
done
have.
lab six, assignment two, and you've done it and you've explored it really well, then
Yeah,
assignment two should be
it should be
completely
okay.
completely doable. It should be very similar.
Okay,
Yeah.
okay. But like, I'm just too worried of connecting again, just in case.
Okay.
So
Running out of hours.
that's okay though, right? Like, so I did it last night, but it's okay
Hmm.
to just yeah, and I downloaded everything in the Pexels and that's all okay. I
Hmm.
don't have to rerun it, right? But I'm sort of just like when I go try to go through it again to see whether I've got answer. Whether I need some
Yeah, I think
help.
if you've already gone through and you know what's going on, you know what the outputs look like, and you've run it a couple times previously,
Yeah.
when you're
And
revising, you don't need to run it all again. No.
no, I don't have to, right? And for this one, I ran it like 4 or 5 times using a sort of like different And I did ask, I think Gemini couldn't help me. I asked Copilot on like what sort
Okay.
of trial I need to use, like, and they gave me a few trial, like adjusting the learning rate. I think that
Sure.
is the one that I'm still a bit confused. I might just look at this and relook.
Okay.
I'll ask you questions.
Yeah,
Um,
yeah, sure.
yeah. This is the one that you know how you ask you to do five different one and
hmm
yeah, and then training of large data set. I haven't looked at that yet. But anyway, yep,
Okay.
I'll come back when I'll
Sure.
relook again.
If
Thank
you
you.
have any questions, let me know and we'll
Thank you.
work it
Thank
out.
you.
Yeah, yeah.
Thanks. How do I stop
I
this?
will stop you.
Okay. Thank you. Thank,
I have the power.
thank you.
Yeah. I didn't mention it in the lecture, but since I forgot about it, I'm sorry. Just a reminder that assessment two, which you need to do lab six for, which we're doing this week, assessment two is due not this coming weekend, but the end of the weekend after. That's when assessment two is due. So keep that in mind. Assessment two is coming up pretty quickly.
What about assessment one, Brandon? I looked at the result, but some of them are marked, some of them are not yet marked. They just say mark out of 30, but there is no mark in there. Is it meant to be
Yeah,
like,
most of them are not yet marked. We're going to be marking them over the next week.
oh, okay. So it's not like automatically marked. I thought you said it was auto.
There's parts that are automatically marked, but there's parts that are not automatically marked, and we need to do the manual marking still.
Ah, okay. Thank you.
Yeah.
Hi, Brandon. Uh,
Hi, Lizanda.
question about the assignment.
Mm-hmm.
Assignment to um cover up to uh
If you
which
can do lab six, the one we're doing today, the second lab sheet we're doing today, then you're completely ready to start on assessment two.
after lab 6.
Yes, after lab six.
All right, thank you.
Yeah.
Hi, Brendan. Hi, Brendan.
Hi, Alessandro. What's up?
I have a question regarding the lab sheet 2. I'm in lab sheet 2 now.
So, like actual lab sheet 2? So from module 1?
Yeah, this next module. Next lab sheet.
The lab sheet 6. Okay.
Hang on. Yeah, lab sheet 6. Sorry, lab sheet
Yep.
6.
Yep. Okay.
And,
Yes.
I'm creating the folder structure. You
Mm-hmm.
can see the train and well folder, validation folder or something. And then
Mm-hmm.
it say of 60 images, randomly select 15 images from each class and place them in the corresponding pixel train folder.
Mm-hmm.
So how we select the images into the train folder?
You,
Random, any of them?
yeah, any of them.
Yeah,
Whichever
why
ones.
why why it's been a class, each class?
So there's 60 images, but
Yeah.
in those 60 images, there are three classes. Or there are, yeah, three classes, 20 images of each, right?
Okay, what are the classes?
Person, flower, and chair,
The person code.
as they're noted above.
Yeah, so a 15 mean 5 from each, is it?
No, it means 15 for each, right? There's 20 images,
Yeah.
15 of each class are going to go to train, and 5 are going to go to test.
Okay. Yeah. Okay, thank you.
Yeah.
Benton. Regarding the classification, when
Hmm.
you submitted a photo, do the computer assign a classification? Like for example,
Sorry, I missed a word there. When you submit a what? A photo, a
like
photo.
a person, like when you submit
Yep. An image, a photo. Yep.
a
Yep.
photo,
Yep.
do the computer assign a classification, the classes?
There is a ResNet model which is being used to assess that image across many classes, and then there is code that checks which class did it predict the highest score for. Yes, so the
Okay,
computer does give it a class.
that's the classes. Okay,
Yeah.
all right. Okay, that's why because the classes is keep on changing and it distributed to the first 10 top classes, right? That's the one. Yeah. Okay.
So
Yeah.
when for this case for the ResNet model, when it makes a prediction for classes, it's going to make a prediction across 1,000 different classes,
Oh,
right?
okay.
There's 1,000 different classes in the data set it was trained on, so that means it can only give us one of the answers from the 1,000 that it's been trained on, which sounds a lot, but it's not every possible thing, right? There's more than 1,000 possible things in the world. So it'll give us its best guess amongst those 1,000 classes. And
Okay.
the bottom graph in that classification part shows you the distribution across all 1,000 classes. And you'll see it's very spiky, right? There's a
Oh,
couple
okay.
that are
Yeah,
really
yeah, yeah.
high,
Yeah,
and
that's right. Yeah.
and most of them are very low, right? In the top right graph, we've just picked out the ones from those 1,000 which it has the highest prediction for.
Exactly. Yeah, yeah.
And so then we've translated it from the index. So instead of it being like class number 730, it's just we give it its proper name, which should be like banister or
Yeah, that's right.
uh,
Batista. Yeah, that's right. Yeah.
or churro or whatever or pretzel or
Cardigan.
whatever
No,
it is. Yeah.
cardigan and sunglasses. Yeah.
Or sunglasses, right? So yeah, what you see in the bottom part is the full distribution, and what you see in the top right graph is like a curated list of the ones that the model think it's most likely to be.
Okay. Thank you.
Yeah, no problem.
Brandon, um,
Yes, Mira.
how why would you use validation data? I'm gonna share my screen.
Okay.
Where is it? One sec. I put them into here. I'm just sort of, well, I'm running. I'm finally giving in to that thing. I'm just using it anyway. So for example, I don't know, whatever. I'm just gonna pay
Yep.
$15 if it has to be.
Yep. Fair enough.
Could you explain this? Like pre-trained,
Number
false.
equal.
Well, I changed it to false. Initially it was true, but I changed it to false. Could you explain
Okay.
it? I'm kind of just
It was true.
yeah. I think the initial one was true, and I think this was 10. And then yeah, but I kind of like not sure.
It wasn't.
What was the first one? I can't remember. I think
It
this.
was definitely false when it started.
Oh,
Anyway,
was it? Okay, okay.
yep.
Yeah. So
That's
like
right.
if you yeah, could you
Anyway,
explain? Yeah.
so just below that, for this explanation, can you just scroll down to the next bit of text,
Here?
like the text beneath that? So there should be another code, there's code cells and there's text cells. Can you go to the text cell? Keep going.
Oh,
Just scroll
yeah.
down a little more. Just there. Too far?
Yeah.
Too far? Go back up a bit. So just there.
Yep, yep.
So this talks about that, right?
Yeah.
So after reflection question 2,
Yes.
it says there are 3 hyperparameters for you to play with.
Yeah.
Pre-trained, number of epochs, learning
Correct.
rate.
Yeah.
So that explains it. Have you read that or
Yeah, yeah, I have. Yeah, yeah.
okay,
That's
okay,
that's
cool.
how I could move around and change but I don't really understand like are we just trying to test for the best graph? Is that what we're trying to do here? To get what is the
Yes.
best? Oh,
Yeah,
okay.
so the goal is to select hyperparameters so that we get
Yeah.
a good/ideal loss curve.
Yes, yes. Yeah. So yeah, so I did sort of like move around ResNet 34, 50, like
Hmm.
for the sake of it, right? But I don't
Yep.
understand why are we doing it? Like, yeah, what does that mean? So what does
Okay,
that mean?
so
Yeah.
you had 2 questions. I'm just going to answer those two. You had asked 2 questions, and I want to answer those questions directly before you continue, okay? You said, why are we doing it?
Yeah.
And what does that do?
Yes.
Why are we doing it? I think I answered before, but I'm going to say it again. What we're doing is we're just trying things, and some of hyperparameter tuning is just trying random things in some
Yeah.
way, in some sense, trying to get a good looking loss curve. So we
Yeah.
want that loss curve to look with that like steep loss going down. So can you diagnose for me that graph there? There's a
This
problem with
one.
that. Yeah, so that one's a bad loss curve. Why is that a bad loss curve?
Because the training go all the way down, right? It has to steep,
Okay.
like going down into the loss. So
Hmm.
that means if we're not looking at this, we thought it was good. But
Okay.
now that we see the validation data, it's not. It's sort of like just going down a bit and then it's gone flat. So it's not sort of like going close
It's
to
actually
the,
worse than going flat. The validation loss is going up at
oh
the end,
yes, it's kind of like going up a bit. Yep.
going up, which means there's a word for that. What's that called?
Overfitting.
Yes, exactly right.
Yeah.
That's called overfitting. Can you
Yeah.
tell me what overfitting means?
You train, I think you're using too much of the training data and then
Oh, that's diagnosing it,
model,
but what does it mean?
uh, that means the model is only completely designed to fit to predict right for the training data, but it can't do well for all the testing data or validation data. Is that right?
Yeah,
Yeah.
that's correct. And not only is it a problem for the validation testing data, it's a problem for just like the idea of it being generally good, right?
Yeah.
Because your validation and test data, they're like an estimation of how good it is in the real world. And so it almost doesn't matter, it doesn't technically matter what you get on the test set. It matters what it would do in the real world. But your
Yep.
test set is like your evaluation of how good it would do in the real world. So
Yep.
absolutely right. Good job on overfitting. Okay, so what are we doing? That was the first question. What are we doing? We're trying to make that be a good loss curve, and currently what you can see there is not a good loss curve. So
Yep.
you're just changing those values however you like, up, down, change from one thing to another, change whatever. Just trying things and trying to make it be a good loss curve based on what you think might be useful based on how you understand what's
So
going
I ended up sort of putting
on.
that into a PowerPoint where I've got like a few, right? So I've got this based on
Okay.
that. And then this is what the first one look, which is
Okay.
what is that called? where is that blue? So this one validation is going up. So this is very bad, right?
Mm-hmm.
What about from the accuracy graph perspective? So the accuracy graph looks like the training is good, right? Because the opposite,
Mm-hmm.
and
Yeah,
then
yeah.
the
It goes up. Yep.
validation is down, right? So that's
That's
just
right.
the
Yep.
opposite. And
Yep.
then, so that is bad. This is validation up. Again, this is not a bad one. Oh, is this the same one? No, it's not the same.
No.
No, it's not the same. So this is um the validation is not moving at all. It's flat.
Okay.
Uh,
Yep.
so that's bad, right?
Well, it is bad in the sense it doesn't go up, but it's also 90%. So it started out pretty good.
Yeah, yeah. So the way you looked at this, right, which
Hmm.
I then realized that maybe I should cut and paste this as well. So by the time when the third one came, I thought I should look at the accuracy numbers as well.
Okay.
Um,
Yeah.
so this one, for example, that means the training is going down. So
Hmm.
this is bad because
Yep.
the yep is going up, and then
Hmm.
yeah, so this is bad. So even though the accuracy is 90%, this is still bad, right? Because
It's bad. Yeah, it's bad in the sense that it's getting worse on the validation set. So if you train that for longer, probably the actually you have to see it. The accuracy at the peak of the loss, the validation accuracy is at its lowest.
here and then yes,
Yeah.
which means what?
It means it could do better. Like it's very we say good and bad in the lecture, and I just want to be clear that that's like a simplification,
Yeah,
right? It's usually better or worse. And so we want to make it better. We can probably choose hyperparameters that would make the loss graph look better than that.
yep,
And
yep,
yeah, you're right. Like 80%, 90% accuracy is not bad,
yes,
but it looks like if we chose the right hyperparameters, we could get the validation accuracy to go up to 90% and stay at 90% if we chose the right hyperparameters.
yeah. And then this one is a good, yeah. So there's not one good one. So bad.
You've only found bad ones.
I'm pretty sure I saw one good one yesterday.
You
So
didn't
this is
save it.
probably one of the, no, this is bad, right? Just now it was really bad, this one.
That's pretty bad. That's the worst because
Yeah,
the validation accuracy is also very bad.
yeah, yeah. So how do you train? Like it just got all of these,
Also,
like,
that's wrong. What you've got annotated there is actually wrong. So if you look at the picture, it actually tells you we made this happen deliberately in the code. So the picture shows that that was actually pre-trained equals false, number
yeah.
of epochs equals 40, learning rate equals 0.01. In the top left, you have different information. That's not what is being shown.
Oh, okay. So that was a wrong cut and paste, was it? Is that what you're saying?
No, the top left, what you have in the top left, that's
Oh,
wrong.
yeah, yeah, yeah. So that is because this is epoch 40.
Yeah.
Yeah, yeah, yeah.
And
So
pre-trained
that could
equals
be the,
false and learning, like all of those values are different.
yeah, yeah, yeah. So I don't know what it is. Maybe I just sort of, yeah.
Maybe you thought it was that. I don't know. Or like, because sometimes it can go out of date, right? If you,
No, no, it wasn't from Portal. I literally cut and paste, but I ran too many of them. It was so late
yeah,
at night. So it was probably late night. That's all.
yeah, yeah. What that's what I mean by it being out of date is that if you run if you run the previous code cell and
Oh,
you run that one and then you change the values and you forget to rerun that, but then you run this one, it'll use the old values previous to
ah,
it. So this is what you see on the graph is the absolute is definitely what it is. And
yes.
if what you see in the code above isn't necessarily what it is because it might have been you might have run the code cell at a different time or something like that.
Okay, okay.
Yeah.
And this is bad, right? So this is accuracy 25. So as soon as you see this is 25,
It's not
you
necessarily bad.
25% is bad.
No, I mean that it may not only stay at 25%. Like so if it starts at
Oh,
25% but then goes up, that's good. But if it starts at, it doesn't have to start at 80%.
yeah,
No point.
yeah,
Yeah.
yeah. Okay.
And so I just
But
want to point
yes.
out your thing is
Mm.
out of date again. So what you see currently trained up there is not what you see as the graph.
Which one? So here is 12, yeah?
So yes, so just like your training loop, the code cell before that,
Yep. Oh, here?
yeah, that's not the graph that you currently are looking at.
Oh. So are you saying that I pressed on this and I did not rerun the graph?
Yes, that's right. That's right. That's what
Maybe
I'm
that's
saying.
what it is. I think
Yeah.
you're right. Yeah, you're right. So that's it, right?
Yeah.
So
Yeah,
this
you
one,
can tell because the accuracy is at 25% or something. And so the other slides you have there, there's similar things going on where you've got mismatches. Um,
yeah. So I probably run one thing and I forgot to run the other.
yeah. So just you should just re review based on this image only. Don't try to write the other things. And I noticed so in the other slide, I actually want you to get rid of it just so it doesn't confuse you. Can you go back to the other slide? And you
Yes.
had like outputs of the run on the third slide.
Yes.
That's out of
Oh,
date as well.
because how do you know?
So that one's fine. Slide three is different. So this one, the validation accuracy is only 90%. Whereas in your picture, you can see that the validation accuracy goes to 100% down to 80%. And so
Oh,
those,
yes.
what's printed out will literally be data points in the graph when they're the right ones. There's no like they're not like different X values or
Yeah.
anything. It's literally it should be those ones. So the what you got in the top right, that's wrong. You should just
Yeah.
get rid
So
of
this
that.
is so this
And
is
the top
this.
left, they're both wrong. They're both like they're not that image.
Oh, I'll abandon this PowerPoint. That is probably confused.
So you just make that one bigger. It's just that. And another thing I want to mention about this is you don't have to take a screenshot. You can actually just
Yeah.
save the image. So if you go back
Oh,
to
can you?
yeah, if you just go back to it, go
Yep.
and just right click,
Yes.
save image as, and then that'll just save it. I guess
Oh,
I
yeah,
guess
but then I
maybe you don't
can't.
want to have to save it.
I
Yeah,
can't
okay, I
split
guess.
it, right? Yeah, I want
Yeah,
to
fair
split
enough. Okay,
it. I sort of just,
never mind. Yeah.
but I still don't understand
Okay. So
what
we
is
answered the first question, and it was a bit longer than I thought it was going to be. We answered your first question. First question is, what are we trying to do? Second question is, what do these even mean? All right.
yeah,
So can you tell me, wait, let's go one by one because it's written
yes.
out there, and I just want to see what your thoughts are on them already, and then we'll talk about them. So what do you think pre-trained means, and what do you understand about it, if anything?
Uh, Pre-trained, I thought is the model like we're using pre-trained we're using pre-trained model and
Hmm.
then we're fine-tuning it by
Yes.
fine-tuning the whatever hyper parameters.
The parameters, not the hyperparameters. The hyperparameters are what you're choosing there. Pre-trained number of books at linear rate. Those are hyperparameters. Remember, parameters are what the computer chooses, and
Yeah.
hyperparameters are what you choose. So if you've chosen what pre-trained should be, that means it's the hyperparameter.
Oh, okay, okay. Yep. And then so pre-trained means the
So
model has been pre-trained.
yes, exactly. So specifically, it means that the weights or the parameters have already got a decent value, right? They
Yeah.
already have been given some value by a training procedure by somebody else at some other time before you get your hands on it.
Okay.
And so
Yep.
you're just
But
down pre-trained true means you're downloading their weights as well as the model architecture.
okay. So
And then you
what
start, and here's the
we're
thing.
doing up here, we're not just training them. We like in here when they say training the model, that means
Hmm.
we are using the model, like we're using what other people has done.
Hmm.
I- Not
First,
we're not training the model.
you are then training the model, as you said, with fine tuning.
Oh,
Yeah.
fine-tuning. Okay.
Yeah.
Yep.
Yeah. So if it's pre-trained is true, that
Okay.
means you're fine tuning from the what somebody else has done. If pre-trained is false,
Yeah.
that means that the weights are just completely randomly selected to begin with, and then they're trained from scratch.
Okay. Which means that if we use the true one, we would think that it will be better result than the false, right? Because true, that means it has been pre-trained by others.
Hmm.
Then we should just get much better accuracy than the false, right? So if I run it now,
Uh,
I
so yes, if the data set that it has been trained on looks like the data set we're using in any sense.
so how do I know which data set we're using?
That was the first part of the lab
Oh,
is creating your data set.
oh, that was the one that you use the
Like
pixels, use all of
yeah,
this.
you download the pictures, you put them into folders, you sort so you sort the pictures into folders, then you create some new
Yeah.
folders with new pictures. Yeah, that was you creating a data set. That's what this is being evaluated on.
And how do I know what the model
Ha-
has pre-trained?
Uh, so you can look up, this has been pre-trained on a data set called ImageNet, and you can look up like ImageNet Viewer, and you can look at the kinds of images it's been trained on, but I'll just tell you, it's pretty similar. It's
Okay.
similar in a similar way. So it's
Similar
ground level
pattern.
images of like natural scenes in houses and outdoors, that kind of things that you would just sort of snap with your own camera from your own perspective.
Yeah.
In that sense, it's quite similar.
Okay.
So
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 it should
yes. So
be
in
good.
this case, yes, it should improve it.
Okay.
It should be
And
better.
then, yeah, okay. So I'll test it later. And
Hmm.
then what about for and epochs?
Number of epochs. That's
Yeah.
how long you're going to train the model for.
And how
That
many
is,
time, how many run they're gonna go through your data set, which is
yes.
okay.
So just to test your knowledge on the number of epochs,
Yeah.
if you have set a batch size, or in this
Mm-hmm.
case, the batch size is the whole data set,
Yeah.
unfortunately, because it's a very small data set, we can't really have a smaller batch size. So
Yeah.
you have a fixed batch size, you have a fixed data set size. If you choose a number of epochs, are you then able to also select a number of iterations separately?
No, because it's the whole data set, right? So the number of epoch is the number of iterations.
Yep.
Is that
Yep.
right?
Yep,
Yeah.
that's right. That's good.
Is that a trick question or?
No, no, you just know it. You just understand it. That's good. That's really good.
No,
Okay.
so doctor, what will happen if ongoing training, like not just a specific data set, like numbers, if it is ongoing training, what will
I'm
happen?
not sure what you mean by ongoing training.
I mean, we feed all the time live data.
Oh, online training. Okay.
Yeah,
Um,
ongoing, it's continuous
yeah, yeah.
training.
Continuous learning. It's tricky. There's no real good solution to it, actually. Uh,
Hmm.
if you're trying to do that, there's a bunch of research into trying to make that work, and it kind of doesn't for a lot of it. The biggest issue you come across is catastrophic forgetting, where if there's any change in the kinds of images that you're showing it. So, for example, you train it on ImageNet, but your business only needs to use it to find dogs.
Hmm.
And so you start getting a bunch of images of dogs and you continually train it on images of dogs. What's going to happen is that the model's actually going to start to forget everything else and it's going to start to focus in on got to be good at dogs, got to be good at dogs because that's all I'm seeing. I'm only seeing dogs. So it'll only learn how to be good at dogs and it'll forget everything else. And so it's called catastrophic forgetting. And it's really hard to deal with that if you're trying to do online training. So most people don't do online training in like trying to add new things, add new things, add new things. You try to do add new things as you keep going, it'll just forget everything else it's learned as you add new things. The only way to do continual learning is to uh, basically update your data set and just
At the bunch.
fine tune on your new data set where you've updated your data set. You can't which means that it still has to be shown examples of everything else that it's been trained on plus the new things. That's kind of the only way that reliably works for that.
Okay, makes sense. Yeah.
Yeah. Good question.
Yeah, because nowadays the models are improving day by day
Actually,
from
on
the data, you
so
know?
people say that they're improving all
Hmm.
the time. They're not literally improving all the time. Do you remember how you have the releases? Like you've seen releases, like say it's the new
Yeah.
ChatGPT
Version.
5.5 or whatever, right?
Yeah, yeah,
Like
yeah, yeah.
the 5.4 was out, and then between 5.4 and 5.5, there was no change to 5.4. It was the exact same weights the entire
Mm.
time. It was never updated. What they were doing was they were taking lessons they had learned and choosing different hyperparameters and choosing different data and updating their data sets and then just doing this training almost from scratch again. And then
Mm.
that's how they
But
get 5.5 from 5.4. It's like they just learn lessons on how to choose these hyperparameters. It's not that the model itself is literally being improved every day. It's that they are just taking lessons and then doing another batch of training at another point in time.
actually, I'm trying my local LLM model training with
Hmm.
my health data and my running and day-to-day activities and everything.
Okay.
So age and other prediction, like every person age and heartbeat and different categories.
Okay.
So do you recommend me not just everyday training, just version-wise training, right?
I would have to look at what you're using. So I presume you have some sort of training code that you've gotten from somewhere to do that. Potentially they have a solution to catastrophic forgetting. I mean, I don't know all of the research that's out there. Potentially there's someone who's got some kind of solution to it. I'm not sure. There's definitely like ways to mitigate it, but it's a serious concern, and so I would be cautious about it. It just I don't know exactly what you're running, right?
Yeah, yeah. Basically, I'm just fetching data from my Strava and Google Health and Apple Health, just live data. Yeah.
But
That's a
what's the code to train? How are
code.
you training?
Fetch my API, the Google Health data set, and then use my local LLM model to train whatever data.
That doesn't sound right to me. I don't.
Actually, I
I
haven't
would have to
fully
I'd have to look at it.
completed.
I'm not sure, but that
Yeah,
doesn't
yeah.
sound like the sort of thing that you can do. I haven't heard of anyone doing that before, so I don't know. But there's plenty of things I don't know about.
So I will do more research, maybe a background study. Yeah.
If you want, I'm happy to look at it. It's just yeah, I don't know what you're exactly running, so I don't have any advice specifically to your case. I would I would just I would say have caution about trying to do a continual learning situation.
Mhm. Sorry, I haven't completed properly, but just still planning. Yeah.
Sure. Okay.
Brandon, just back to
Hmm.
this one. What
Yeah,
is
sorry, Mira.
no, it's okay. No, like for this epoch,
Hmm.
right? 40,
Yep.
why does the step go down to 2, 3, 40?
That's the number of images that it's seen.
Isn't it say steps?
Yeah, you can count
Brandon,
steps
I've
as
got a next question, okay?
sure, sure, Paul. Yep. Um, so it's yeah. I mean, maybe you could say it's mislabeled. It's a number of images. And
Number of images, right? It's not then,
yeah.
yep, sorry. And the
So
last
each
one,
so each 60 is one batch because there's 60
yep,
images. Yeah.
sure. Sorry, I'm just gonna, the
No,
last
that's
comment
fine.
is that this one looks
Hmm.
good because I used true, and
Hmm.
this is good, right? Because then the loss gone all the way down here, and
Hmm.
same as the validation, and then the accuracy gone to the one, which is good.
It's good until it gets to like past 1,000 steps. Then it
Eh,
starts to get kind of not good.
yeah. So it start to go down like that, which means
Yeah.
yeah. Okay,
So
okay.
so how would you fix this?
We just change the epoch down.
Yes, exactly.
Yeah.
Yep, you can.
Sorry, Paul. I know you're gonna ask a question. The validation,
Hmm.
why do we use validation? Why do we not use testing? Like I know your answer,
If
the theoretical
uh,
answer is that you don't want to touch it, but why?
so if you tune onto the test set, you are lying to yourself. You are telling yourself, "Oh, I have this model that works really well on test set." But the reason it works well is because you've selectively chosen the ones that happened to work well on the test set,
Oh, okay.
which is a lie. It's not that it would work well in general, because the purpose
Yeah.
of the test set, right, is to test whether it would work in general. It's not
Yes.
that it would work well in general, it's that it works well on these particular images. And so
Ah,
you've got to avoid, it's really hard, but it's like a confirmation bias thing. It's like, oh no, this thing got a good thing on the test set is how you feel,
yeah.
but it's kind of tricking yourself.
Okay. Yeah. Okay.
Yeah,
Got it. Thank you. Sorry, I'll
that's fine.
send to
All right,
Paul.
Paul.
Okay, this is with lab 5.
Lab
Okay,
5, yes. Okay.
segmentation. I'm not
Hmm.
getting that bit where we need to display the image size and the segmentation size.
Can you give me a
Yeah,
reflection question?
let me
Or is it
can I
not a
share
reflection
that?
question? Yeah, you can share screen. Yeah.
Let me share, let me share, let me share.
Share, share, share.
Where is it? A whole bunch of options now.
Not sure. For me, in the
Me
Zoom
to
window, Share is in the middle of the main window at the bottom,
Yeah.
next to React and Chat and
Go here. Not sure if it will share. No, it won't. Damn it.
oh. Try again. Sometimes it takes two tries for some reason.
We'll try again. You'll see I'm double on this thing. It's my privacy and security settings.
Okay.
Yeah.
Well, just maybe I'll share my screen. You can direct me
Okay.
if
Thanks.
you want to do it that way.
Yeah.
Let me just bring it up and then we'll share that and we share that and go there.
Bring up my
So
screen. Okay. So segmentation. Let's go
yeah,
there.
sorry, give me a second. I'm just gonna play through this
Okay.
so that we have everything ready. Okay. So where is it? Is it reflection question 6? No, I think you were down to maybe
Check it
reflection
out.
question
Reflector
7, somewhere
7, yeah.
between.
7.
So you
I'm not getting the response from that print image size, image numpy shape. Yeah, it's
okay.
giving me a box, yeah, the size of the image. Okay, why they're
Okay.
the same, I don't really get. And also the color is different. Is that the actual physical color they're putting out?
Okay. I think I know what you're talking about. So you're talking here. We have image
Yeah,
size, we have segmentation size, and we're like, okay, so that's the height, that's the width,
yeah.
and then for the image, that's the color.
So is that the red and the
The
green
red, the green,
thingamajiggy in
and the
the
blue.
image? Yeah.
Yeah. So you have
So
3 sets of maps of 520 by 779.
3 sets. I thought that's just the color.
Yeah, so there's a red version, there's a
Yeah.
green version, and there's a blue
Mm,
version.
I don't see any blue. Maybe that's what threw
What do you
me.
mean you don't see any blue?
So if you scroll up, see there's only red and green.
Oh, this is not,
There's nothing to do
that's
with
not
that.
color. No,
I
no,
thought
those,
the
are just
image size
colors.
had to do with the
Hold
image
on, hold on,
of
hold on,
that
hold on, hold on, hold on,
husk
hold on, hold on,
Siberian
hold on, hold on,
husky.
hold on, hold on, hold on. Sorry. I really want to cut you off because I want to clarify. This has the colors in this
Yeah.
have nothing to do with the red, green, and blue channels of the color image.
Okay.
Sorry to cut you off. I just really want to need to make
That's
that very,
cool.
very clear. These colors, the fact that this is not red either. This is like a magenta. This is not
Okay.
green. This is a lime color, right?
Granted.
The red, green, and blue for color images is full red, only talking about red. The green is only green. It's only talking about green. Um, so when we're talking about these, we're talking about all the way at the start. When we're talking about images. This is what we're
Yeah.
talking about,
Okay.
right? We have a red map, we have a green map, and we have a blue map.
Of
All
the
color
image.
images, all color
Okay.
images in a computer work this way.
Okay, cool. I get that. So
Yeah.
the image size, when
So the
the
image size.
numpy, the
Yep.
image.numpy.shape, that's going to
Mhm.
say it's got 3 images, red image, green image, blue image. The size
Yep.
is 520 by 7. That's the
79.
length and the breadth, yeah, basically.
Yeah. Yeah. So this is the
And
height
then,
and the width in that
yeah,
order. Yes.
so
Okay.
segmentation shape, what is that? Because now it's
Yes.
21 images. So what is
hmm
that?
hmm
What could possibly be there? It's not red, green, blue.
It's not red, green, blue.
Yeah.
No.
So then there's like so much information there. I'm not
There's a
getting
lot
it.
of information. Okay. I'm going to pull it back to the image and we're going to just think about the image slightly differently. Okay. So I started with talking about there's a red map, there's a green map, and a blue map because I wanted you to be able to, like, in your head, swap between two different ways of thinking about this.
Hmm.
So there's one way, which is where you have the red, the green, and the blue separate maps. And that's one way. The other way we can think about this is that there's 550 by 779 pixels, and
Mhm.
inside of each pixel is a red, a green, and a blue. Are you comfortable with that as well? Does that make
Yeah,
sense?
I'm comfortable with that. Yeah.
Okay. So we're going to, for the segmentation, we're going to think about it in this second way that we've started talking about. So
Okay.
we have 550 pixels by 779 pixels, and then inside of each pixel, there's 21
Exactly.
somethings.
21 somethings. What is the
Somethings. They're not the
somethings?
red, green, blue, they're somethings. Okay.
Yeah.
What those somethings are classification scores, just like classification.
Ah, okay.
So you can see for this image, there's 1,000 numbers coming out because there's 1,000 classes, and it has a score for each of those 1,000 classes. For the
Okay.
segmentation, what it is there's a score for 21 different classes,
Classifications.
and that forms a classification, right? Because it's a
Mhm.
score for 21 classes, and then you find whatever class was the highest among those 21 is the prediction for that pixel.
Yes, I do get that, but
Okay.
I'm a bit confused. I want to just clarify something. So the
Hmm.
21,
Mm.
are three of them red, green, and blue, or is
No,
it totally extracted? This is just
totally.
about this is
Yeah.
just
So
about what we the classifications that we're putting on the
just the
pixel.
classification. So it's an image shape, but it's not like an image you could look at already,
Yes,
right?
I'm getting it.
Okay,
It's
that's
making much
good.
more sense now.
Yeah, okay. If you get
Okay.
that, let's dig a little deeper into this visualization that I was so anal about.
Yeah.
Sorry about that.
No, it's
Um,
fine.
because what we see here is literally a color image, right?
Yeah. But it's the classifications, right?
But it's classifications. So there's
Yes.
actually a translation that has to happen, right?
What do you mean? Translation.
We have a translation from this 21 things. What we do, I'm just going to describe the steps, and you can look at the code to see it happening,
Yeah.
but I'm just going to describe it. Hopefully, it makes sense. So we have this. So just look at one pixel. Only think about one pixel. That one pixel has 21
Mm-hmm.
class scores in it. And we want to get to the end point where we say, okay, we've colored it for display as this magenta color. And then I'm going to talk about the in between, okay? So the first thing that happens is we have a score per class. We have to decide
Yeah.
which class is it
There's a
actually.
21 things. Yeah.
There's 21 different
Yep.
things. So which class had the highest score? So we take
Yeah.
the class index that has the highest score, okay?
Okay.
And then we've chosen one of them. Now we've got an index. Now we've got just a number, some number between 0 and 20, right?
Yeah.
That tells us, and that's like a class. Let's say it's backgrounds for a lot of them. So we say the pixel was
Yeah.
background. So the highest score was for class 0.
Yeah.
Okay, that still doesn't tell us how we make a color image out of that.
Doesn't it? Because it's 520 by 799. So it's 21. The highest score is what we color the pixel with. So we say
Yeah.
0 is that magenta. Yeah.
Yeah. So that's
Yeah.
actually that step there. You just intuited the answer, but when we're coding it, actually you have to do
Yeah.
that explicitly, right? You have
Yes.
to
You have to
say
do it for each
index
pixel.
0 is this
Yes.
magenta color. Index
Yes.
1 is this lime color.
Yep.
Index 2 is this other color. And so that's how you color it. That's how you
Yeah.
make this image. Yeah.
Yeah.
So you intuited the correct answer. That's good. Yeah.
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 Cool.
Nice. Good job. I'll stop sharing.
Thank you.
Nice job, Paul.
I can see 8 and 9 are how we furthered the conversation.
Sorry, say again.
Reflect question 8 and 9 that they're building that image up that we just went through.
Yeah, they are.
Cool.
Good.
Brendan.
Yes, Abelardo. What's up?
Good. Now, I'm now looking on the detection says alignment bonding. Do you mean to say that the computer is have an algorithm to do the iteration to make sure the IOU is higher than 9 by moving the image by moving the block to be in the middle of the I mean, in the image, moving the boundary inside the image, correct? Is that the
Uh,
way?
so
Is that the
your
way?
goal, you are going to be optimizing the IOU. You're trying to
I,
make the IOU larger by
I
choosing
understand. I
whatever
understand.
values.
I
Yeah.
understand. But in the real scenario, when
Mm-hmm.
you're teaching this one, there's an
Yes.
algorithm by the learnings to move this one
Yep.
to yeah, correct.
That's
So
right.
there's a
Yeah.
yeah.
So basically, this is part of the loss function for
Yes, yes,
detection.
yes, yes.
You're going to measure how wrong is the model. Well, it's predicted this box, which is close to this other box, and that box is they're close, but they're not right. So that's part of the
Yeah.
and it's like you get the IOU, and that tells you how wrong the
Okay, okay.
the model is in another way. So you've got classification way that's wrong, or the box way is wrong, and it can be
That's
wrong in
right.
either way.
Yeah, that's right.
Yeah.
So there's an algorithm inside the learning process behind it. All right.
Yes,
Yep.
when you're learning when you're training a detection model, you
Yes.
use IOU as part of the loss function. But
Okay.
as we've said, all machine learning, they always have the same basic parts of the data, the model, the loss function, and the optimization algorithm. And so the for training a detection model, it's just that the loss function is sort of a bit more complicated. It involves both the classification and the box IOU.
Okay. Now, I just want to take
Good question.
your advice.
Okay.
For the past few lessons, we got about the confusion matrix, right?
Yes.
All the accuracy and recall. I mean, they
Hmm.
have sometimes it's very difficult to memorize the true positive, true negative. Now, is that
Hmm.
very important for you to understand it very on
It's
heart?
important for you to understand. It is not important for you to memorize.
Oh, okay, okay.
Yeah. I
It's-
would say I still look it up half the time.
and the other thing is I try to understand it by heart, but it's just
It's too tricky to memorize.
so
You just have
tricky
to
to
know the
memorize. Yeah,
ideas. Yeah, you
yeah,
just have
yeah.
to all you have to know is the ideas. And so when you look it up, you go, "Yep, I know what that's talking about." That's all we want you to do. You don't need to memorize the confusion matrix itself. That being said, you should be able to read a
Yes,
confusion matrix. So if you
yes,
see a
yes, yes. I
confusion
understand.
matrix, you should be able to say,
Yes,
"Oh, it's wrong on these things and it's right on those things." That's the skill that is best for you to have. Yeah.
yeah. Okay, I say I'm a bit concerned. You put everything on theoretical one, but sometimes it's theoretical. When you do the actual lab, you
Mhm.
don't even think about it. You don't even feel
It's
about it.
obvious.
Yeah, that's right. Anyway,
Once
thank you
it's
very
obvious,
much.
that's good. That's good when it's obvious. That's what we want.
Thank you very much.
Yeah, yeah, it's all good.
Sorry, Brandon, I got a question. Can I
Yeah.
attend the lab on Friday?
Yes, I'm happy for
Okay,
you to attend the lab on Friday. Yeah.
because
There's two
yeah,
labs on Friday. You're welcome to come to both of them if you like.
thank you.
Yeah.
Because yeah, I gotta log off now.
Yep,
Thank
fair
you.
enough. Good
Bye.
luck. See ya.
Thank you. Bye.
Hi, Brandon.
Hi, Lisantha. What's up?
I have questions about the training the model in
Okay.
Lab 6. And,
Okay. Yes.
um, you know, there's an instruction to change uh, uh, the model, I mean, parameters. Yeah?
The
Here,
hyperparameters. Yes.
hyperparameters,
Not the
treat,
parameters.
yeah, Boolean values like true and
Hmm.
false and epochs, yeah,
Yes. Yes.
and
Understood.
allowed. So, I got the graphs, for the default values.
Hmm.
But what is we are going to achieve? Like what should I see as a
Yeah.
perfect?
Sure. So remember in the lecture we talked about the ideal loss curve. Would you be able to describe what the ideal loss curve looks like?
It's losing, what's that?
Loss?
Decrease in the loss and
Hmm.
then also closing the gap. Huh?
Yes, it's not just those. We also want to see that the rate that the loss goes down sort of plateaus as well,
That is okay.
right? So the loss should go down a little less, should go down a little less, should go down a little less until eventually it's kind of not going down at all. That's part of what we want to see,
That's what. Yeah, okay.
right?
So
Because
I change.
if it only goes down and it's
Yeah,
still going down and it still looks like it would keep going down if we kept training, that means we're not training long enough.
yeah. Actually, my one's going up.
Yours is going up. Well, okay.
So can
There's a
I?
few reasons why it could
Yeah,
go up though, right?
yeah. Can I show you my model?
Yeah, yeah, absolutely. Share your screen. That's fine. But yes, going up is obviously bad.
Yeah.
Yeah.
So
Okay.
I change here. Uh, these ones I made it true,
Okay.
and then 20 and 01. Then
Hmm.
I got this one.
Mm.
So I don't know which direction, I should, how can I change the direction and then,
I mean, okay,
yeah,
so just often, not so often. Sometimes it's best to only change one thing at once, right?
one in once. Okay.
Because if you change three things at once, you're like,
Yeah.
what caused it to change? What made this happen, right? So I would recommend changing one thing at once and then seeing what happens, and then trying changing one other thing, and then changing one other thing. It might be easier to follow what's going on, right, and see the effect of each thing. Um,
So that way, for example, what could be the effect, if pre-train true and false, uh, and
so there's kind of a theoretical answer to that. So for pre-trained, if the data set you're using is is in a lot of ways similar to the data set
okay. So actually, I put uh, uh, dogs pictures.
bad if if they are, you know, if the data sets are aligned, if they're doing the same thing. If your data sets are not aligned, then it's sort of a mixed bag. Maybe it's good, maybe it's not. Not really sure. And you can do a sort of gut feel analysis, or you
Yeah,
can just say if it did poorly, then there was a poor alignment between the data sets. There's another way of thinking about it.
yeah.
Um,
For example, I put dogs pictures.
okay. And it
So
was
you're never
trained
gonna,
on
never
ImageNet.
gonna. Yeah, I think because the dog picture's not gonna match with the flowers or anything. Is that what you mean? Or
No, what I mean is so when we pre-train, right, we have a model that has already been pre-trained on a data set. And so when it's pre-trained on a data set, usually it's a big data set, it's been trained really well, and it's got a lot of effort been put into getting the weights being really good. And then what we're doing is we're taking both the architecture and the weights, and we're
mm,
bringing it across, and then we're going to tune the parameters even more, but only on our data set, not on the previous data set. And that'll work well when the previous data set, the data set that it was already pre-trained on, when that data set is similar in a lot of ways to the new data set that we're using here right now to train the model. So the question is whether the ImageNet data set, which is what this model was trained on, whether that ImageNet data set is similar to the data set that we're training it on.
okay,
And
right,
I'll tell you now that it probably will be, especially ImageNet has a lot of dog images. It has seen a lot of different kinds of dogs. So,
okay.
so uh, should be very good alignment. If you're using a pre-trained model, you should see a big improvement. And it looks like there is.
So
You have to
okay,
rerun that cell as well. So
return
you've already run the first one, so you need to rerun the next one.
high is it?
Yeah, so you need to rerun this to find out how well it did. And look at that. Did that work well?
Uh, so this is the, yeah, I think it's working, huh?
How can
Like
you
it
tell?
was going down.
Loss is going down. What about accuracy?
Uh, accuracy. Accuracy is given by this one, huh?
Yep.
Going up.
Not just going up. How accurate were they? How accurate was the model?
Um, how to get that? Sorry about that, this.
So on the y-axis of the accuracy graph, you can see the numbers 0, 0.0, 0, 0.2, 0, 0.4, 0, 0.6, 0, 0.8, 1.0, right?
Yeah.
So the 0.2 says if the line on the graph at the step was at 0.2, that would say the model is 20% accurate. If the line's at 0.4, that means that the model was 40% accurate, 60% accurate, 80% accurate, 100% accurate. So where are the lines on that graph?
So this, I'm talking about this graph, huh?
I'm talking about that graph. So where are the graph lines, the colored lines?
Colored one. So this is, I'm not sure it's going through this. It's here.
Yes, it
One,
is.
it's 100%.
It's 100% accurate.
Okay.
Is that good?
That's definitely good,
That's pretty good. Yeah. So did this go well? It went pretty well, right?
Yeah.
The
So
loss went the loss went
just
down dramatically
yeah.
and the accuracy went up a heap. So that's good.
So one parameter change, it works, huh?
Yep. You can try the other parameters, see what they do.
Yeah. So this mean, so
Mhm.
anyway, it's keep the gap consistently
Yes,
and then
they get to
it,
0. Yeah.
make it to zero.
hmm
What's that mean by the make it to the zero?
It means it's perfectly accurate.
Ah, so I don't need to run anything, yeah?
I
Just
think you should run the other ones and see what happens. So you changed, for example, if you make the learning rate 10 times bigger,
10 times bigger.
so just get rid of one of the zeros and see what that does.
Right.
Does it still like because you've got a pre-trained model, the pre-trained model is good. Is that going to break it? Like, is that like you want to find like we're trying to find a sweet spot for the learning rate.
Okay.
And we know what it is, but we want to know like how sensitive is it? Like if we change its learning rate by 10, factor 10 one way, is it going to break it or is it going to be fine?
Yeah. And for this epochs,
hmm
and you know, there's a 40 in there.
hmm
So any number can fit here, or I mean, what? How
Yeah.
do you? Huh?
I mean, you want it to be, you need it to be large enough so that you can see the loss going down.
Large, but this data set,
The
it's
this
not
data
depend
set's
on
pretty
the.
small, so like if you can see the loss going down in just 10 epochs, that's fine. In fact, you saw before in the graph, like because it hasn't updated the graph. So if you scroll down to the graph
Uh,
that that you've just created, right? If you look at this, that was 40 epochs. You probably only need to do 10 here, and it would be fine, right?
so the lesser the epochs is better.
No, not always. In this case, it is because the model learned very, very quickly.
Okay.
But in most cases, you need to increase the epochs. So in like a larger data set, and you'll see that in the second half when you're training on a larger data set,
Yeah.
um, it'll sort of keep going down, keep going down, keep going down. You're like, oh, maybe if I train it for longer, it'll do a bit better. Like that's sort of the thought process. If it's so long as it keeps going down, maybe you can keep training. If you train it for twice as long, it'll do a little bit better on the larger data set in the second part. This is just sort of because it's a toy data set, some of the things don't behave the same way as they would for a larger data set. And this is one of those cases where usually more epochs is better. If your data set is large enough, more epochs is pretty much always better. It's just do you have the time budget to spend on more epochs?
So the larger the data sets, epochs, consume more computer power. Yeah.
They consume more compute power and you need to do more of them. Yes.
Uh,
Damn, that validation loss is really big, huh?
uh, how do you say that?
So the numbers that are being printed out, It's
Yeah.
kind of a table. In the
Ah,
first
okay.
column, you can see there's 5 columns there, yes?
Yeah.
The fourth column is the validation loss.
Ah, okay. Yeah.
And so you can see that it's gone 45, 11,629,000, 2 million. So it's gone up dramatically. But then it's going down, which is weird. Neural networks are weird. Then
Yeah.
goes down to 110. All right, so rerun
That's
the graph and see what it looks like.
oh no, not this time.
Yeah, so that you can see it spiked up, and that's 10 to the power of 11 loss. That's a massive loss. It's a ridiculous loss. So what was different between the last run and this run?
This is actually fluctuate, and then I don't know what is this
No, the
happening.
hyperparameters. What did you change in the hyperparameters?
LR.
The learning rate, yes.
Yeah.
So what does this tell you about the learning rate? Like is 0.01 good?
0.01. Is that the one?
That's what we're currently looking at. Is that a good learning rate?
No.
Okay.
What is? Yeah. No.
What about what it was before? What was before was 0.001. That was a good learning rate, right?
Yeah. Yeah.
So the difference between working really well and completely bombing, like doing absolutely nothing, is like 0.01 to 0.001.
So that makes a difference, huh?
It makes a big difference, right? So you could go the other
So
way, and now you could
yeah.
try learning rate 0.0001 with 3 zeros, right?
Okay.
And see
Here.
see what that does. And this is kind of what it's like when you're training models. It's just like, oh, try this, try that, see what happens.
Yeah.
See what
Of
improves.
these three parameters, which one uh, consume more time?
I would say you spend most of your time tuning learning rate,
LR.
LR, learning rate. Yes,
Okay.
that's right.
So I assume this is gonna be a bit longer.
No, no, the learning. So my answer, because okay, there's two different answers to the question. So you asked which consumes the most time, and I interpreted that as how much which consumes the most of your time when you're tuning it. There's another way to interpret that question, which maybe is what you meant, which is if I change this, how much is it going to change how long it takes to run it
Yeah.
once? And the learning rate has no effect on that.
Okay.
The only thing that affects that is number of epochs. So no, if you change number of epochs, that changes how long this part takes to complete.
Yeah. Let's see this one.
Yes, it's only half done.
Yeah. And also, if I change this back to the best uh process, uh
You mean
would
the
give
point
me the
zero
same
zero one?
answers, huh?
It won't be exactly the same, but it should be pretty similar. Yeah.
Same,
Yeah, if some occasionally, sometimes it's really annoying that the model is learning randomly in the sense like the if you run the same code twice, you'll get a fairly wildly different answer. That happens when the model actually has no idea your training loop is not working properly. If it's not stable between the runs, then it's kind of not doing well in my opinion. But that's kind of a more advanced assessment of training performance.
Yeah.
because of the randomness, huh?
Yeah, because if it's random and unstable, you're falling into that thing I was telling Mira about how you might be like misleading yourself. Because
Yeah.
if it's performing randomly and then it randomly works well, that kind of doesn't mean that your hyperparameters are good. It means you're lucky.
Okay.
Yeah. So
Brandon, like how you're trading on these, but there's
mhm,
also the next question on the large data.
yes.
Um, there was then a question of like, what is the difference? I think on the reflective question, um, What
Hmm.
does it mean by the large data? Like, is it a complete data set all together compared to the MNIST versus the large data, the one that you have to run for like,
MNIST.
whatever.
Sorry, that's fine.
Yes.
Uh, so you're looking at reflection question 9, I think.
Yeah, yeah. Compared to the one that Lasanta is running at the moment, then the next one I think it's on the large data. What is the
Uh,
difference? I guess that's the question.
okay. So MNIST was the
Yeah,
data set we used in lab sheet 4.
correct.
Do you remember it? Can you describe it for me?
Describe the MIS.
MNIST data set. Yeah. Do you remember the MNIST data set
Is that the one
in
that
lab 4?
you go to the Pexel, the one that you have to like,
No.
oh, um,
MNIST was in lab sheet 4. So last
oh, so
week.
that was the one that was last week. No, I don't remember. What was that?
That was the handwritten digits.
Oh, yes. Yep, yep, yep.
That's MNIST.
Okay.
So this question is asking you to compare this new data set of Food 101
Yes.
to MNIST in terms of image variety. So let's start with that. How much image variety is there in MNIST
Yeah.
compared to this Food 101 in terms of like how different could they look?
Will be very different, right? Because the MS is very small.
MNIST has 60,000 images.
Oh, but this one isn't it 100 over 1,000 data? If
We're only using 10 classes, so we're actually only using 10,000 images.
Oh, okay.
But I'm talking about within each image, right? Or across like a handful of images,
Mm-hmm.
how much difference is there between in how it looks, like in terms of lighting, uh, colors that are available, in terms of where the thing appears in the image, right? So
Yeah.
for Food
But
101,
mm,
you have images that are like lit differently, different zooms, different
yep,
focus, different like lenses. For MNIST, you have digits which are black and white and they always in the center and they have a
yep,
different sort of a different shape.
yep.
So it's not like you can say one has definitely more variety, but it does seem like there's more detailed images with more depth and more things happening in food compared to
Yep,
MNIST.
yep.
So that's the comparison you want to make. That like there's more stuff happening in Food 101, and there's more colors, there's more things that can vary within the image compared to MNIST. And that's the first point. That's image variety. All right, and then you go on to image size. It's maybe a bit easier. How big are the images in Food? How big are the images in MNIST?
Oh. Why, like, what is the point of doing this?
Uh, so that you're aware of differences, these kinds of differences within data sets. These
Oh,
are
okay.
when you're evaluating a data set and you're saying, what is this data set good for? What can it do? You look at these things.
Okay. Oh, so if we're just looking at this, literally this thing, like image variety, image size, data set
Hmm.
size. Oh,
Yep.
okay.
Yeah, yeah. For each of them, you want to say what's different across the data sets.
Oh, okay. So this is just basically comparing. Okay, okay,
Yeah,
got
just
it.
comparing. Yeah.
Yep, 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 yep. And then the confusion matrix, which is the testing data, um,
Hmm.
the one right diagonally across the middle, right?
Hmm.
That basically showing say 233 or 171 or like across diagonal, that
Hmm.
means they are correct. So we want that to be
Hmm.
as large as possible.
Hmm.
Whereas the one to the left and to the right side of the diagonal, they're all mistakes, right? And we don't want
Hmm.
any outliers. Is that right? That's how we interpret
Yep, that's
this.
right. That's
Okay.
perfect. Yep.
Yeah, yeah. And then,
Yeah.
does it tell any recall, whether any of them is called recall or precision, or it just doesn't mean anything?
Um,
To the left of the diagonal or to the right of the diagonal, does that mean anything or
so do you, I have to. I have to go back to the lecture. I'm going to bring it up. So I have to
oh no
go.
no, that is actually number 9. Sorry, this is evaluating the model test set. So after we run it, I I can show it to you once. Sorry, I was interrupting Lasanta. But once Lasanta finish, I can show it to you quickly.
That's all right. I just want to ask you a quick question. This,
Okay.
compared to the previous one, this is uh, not good. Yeah? I mean, the last one is much better. Yeah.
I mean, it's fine. Like it looks mostly like the ideal loss curve. Probably obviously we know that the learning rate could be higher, but I mean the shape of it, if we didn't know that we could do better, I would still look at that and go, that looks good. That looks fine. Yeah.
Yeah. Okay.
Yeah. Okay. Is that all?
Yeah, that's all.
Okay, cool. Uh I'm gonna
Can I
kick it
share my
off.
screen quickly?
All right. You can share your screen. Yep.
Thank you. I think I can't. Yeah.
Yep.
I'll be really quick. Um, is that the one? Yes. Yeah.
Yep.
So here, this one,
hmm
right?
Yep.
So you
Yep.
run, the accuracy is 71.
hmm
And on here, so this is good. So what I'm trying to say is on this
hmm
left-hand side compared to that left-hand side, does the 67 mean anything? What if the 67 sits over here? That basically just means the true label is low and the prediction is, because this is prediction, this is true label, right?
Yep.
Um, so that
Yes.
means in
So
here, yeah,
yeah.
sorry, keep going.
Yeah, so you're asking if you flipped it along the diagonal,
Yes.
would it be meaning the same thing?
Yeah.
Yeah, and the answer is no.
Okay.
Specifically with respect to recall and
Yeah.
precision. So I'm stopping your sharing because I want to show you from the lecture. We talked about this.
Yeah.
When we have a multi-class confusion matrix, the
Yes.
definition of recall is the true value divided by the sum of the row. So if you flip it along the diagonal, the recall is going to change.
Oh,
Yeah?
yeah.
So if we flip it along the diagonal, let's just look at what that looks like. What does that mean here? It means, let's say this C one here gets put here, right? That's flipping along the diagonal. This C1 gets put here.
Mm-hmm.
That means that uh, what was the model predicted C, but it was actually A,
Mm-hmm.
becomes the model predicted A, but it was actually C.
Oh. Oh, yes.
Yeah?
Yeah. Okay. Yeah.
Yeah, so
That.
it's not the same idea. And the thing is, if you flip it, recall becomes precision.
Yeah. So which part of so if we're looking at that diagonal,
hmm
the underneath, like, sorry, I'm gonna show my video so that I can use my when everything
Use your
fails,
hands.
you're gonna have to use the so you
Yeah,
know how
yeah.
you go like that, right?
Yeah, yeah,
And
yeah.
if you go underneath here, like down here, is it recall? Up there is precision.
No. No, recall is the row, precision is the column.
Oh, okay. Recall is the
Is the
uh
row,
row.
and precision is the column.
Okay, it's a column here.
Yeah. So it's the proportion that are correct in that column.
Okay. Yeah. Yeah.
All right, so last step, I know we're over time, but this is really important for understanding what precision is and what recall is. I just want to ask you to try and make an English description
Yeah.
of, let's say, recall, because that's currently on screen, right?
Yeah.
What's the English level description of what recall is?
Oh, yeah. So this one recall is if you're predicting A out
hmm
of the fruit, out of the whole A. So you're predicting correctly.
I think you've got the right idea. I think your language is a little incorrect, but I think you've got the right idea. Yeah, I want to be more specifically, out of all of the there's images that are A,
Yeah.
how
Yeah.
much we're correct.
Yes. How much you're predicting correctly, right?
Yeah, how much you're predicting correctly out of all of the ones that actually are A.
Yes.
So what's the English description
So
of precision?
precision
Yeah.
is out
Out
of
of
all the predictions
yep.
that it, out of all the predictions
Mm-hmm. For class A.
for class A,
Yeah.
how many of them that you get correct?
Exactly. Yes.
Yeah.
Yeah.
But it
Good.
still doesn't answer my question of that chart. Which one is like out of that diagonal,
Mm-hmm.
whatever that is underneath here, and
You
compared to what is
shouldn't think about like the triangle that is underneath the diagonal. That's not particularly meaningful.
oh, okay. It meant nothing. Yeah.
Yeah,
This mean it's wrong.
there's no like thing you do with the triangle area at all. You
Yeah.
only talk about rows and columns, and you only talk about the diagonal. You don't talk
Yeah.
about like the triangle above and below. They don't mean anything like any. There's no defined concept that they relate to.
Yeah. They're
Yeah,
just basically wrong.
they're just
It's
wrong. Yeah,
okay.
they're just ways that the model is wrong. Yeah,
Okay.
exactly. Yeah.
Okay. All right. Thank you. Sorry, we're
All
over
right,
time.
thanks.
Thank you.
Yeah. It's
Thank
good.
you.
It's good learning. I'm here for learning. That's
Yeah.
what I'm here for.
Thanks
Yeah.
very much. See
All
ya.
right. See ya.
Bye-bye.
Have a nice evening.
Um,
Do you have
Brandon,
a
one more
question?
question. No,
Okay, you got 2 minutes. You got 2 minutes.
no, just feedback. So
Okay.
that I ran the model same parameters.
Yep.
That we were talking about the parameters. I've changed it back to
Mm-hmm.
the previous parameters,
Mm-hmm.
and the model didn't work. Model did not perform well. Like
Didn't
that.
perform well. Okay. So that means it's a bit unstable. So maybe we
Yeah,
want that learning rate to be somewhere between those two, right? Because it would be more stable. It's generally more stable when the learning rate is lower, right? It's a smaller number. There's more zeros. I mean, it'll always be more stable that way because it's jumping around less. Like the weights are changing less with each step, so it'll be more stable. So if you're noticing that it's unstable when you have
yeah,
that 0.001
yeah.
and
It's
zero
zero.
point zero 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 one three zeros is like really smooth. That's really stable and smooth, but it's not that fast. Maybe it doesn't. Maybe we think you could
Yeah,
probably train a bit faster. Then we should choose a learning rate somewhere between those. Does that make
yeah.
sense?
Yeah, what I did was now
Mm-hmm.
currently I'm running with 10 epochs and 001 LR. That
Sorry.
is
Okay, but that's still too high, isn't it? You said that was unstable.
no. Now because it was unstable, I changed it back to 0.1 LR and 10 epochs. So this one running it is slow.
Okay,
Yeah,
sure. All right.
yeah.
Yeah.
Anyway, I'll let you go.
That exploration is like the point of this lab. It's good for you to see those things happening and like really process it. So I'm glad that you're looking at that and really thinking about it. That's really good.
Yeah. Anyway, I'll let you go.
Yeah, all right.
All
Good night.
right. Thank you very
Have a
much. I
nice
appreciate
evening.
that.
See you,
Thanks.
everyone.
Thanks. Thanks, Mo.